costing her, but I think it was my last hour. Is it -$1.06? Am I supposed to put the negative go in front of the dollar sign?
It's better.
I like this better. Is that what you're saying?
Yeah.
Yeah. It's not wrong either way. Okay. So again, like you'll see this kind of same kid situation come up. Could I play this game once and lose $1.06? It's not even possible because it's not one of my three outcomes. But if I played it over and over and over again for eternity, I would on average lose this amount per time. This is basically casinos. You go in, you might win $17, you might win $2, but the more often you play, the more likely you are to lose an average of this per turn. So every time you're playing a game, they're kind of theoretically collecting $1.06 from you every time, and then they have so many people playing, and you're playing a lot that over time you just can't overcome like the expectation, and they're going to be breaking in the money like one game at a time. Could you go to the casino and play like for one night and win money? Yeah. But if you play for eternity, you're going to lose. It's just the fact. So should she play this game if her expectation is to lose money on average? I mean, she wants to like donate to someone. No, because we expect the expectation is negative. So then if you flip that, the expectation of whoever is running that game is plus $1.06. So they want you to play as much as possible. Alright, number 7. I'm going to kind of skip around. I do want to do 7. So take a look at it. I'll give you a chance to try it, and then we'll talk about it. I don't know who got this far or not, but there is a challenge in the back. We're not skipping that. I don't think it's that much of a challenge. Not that it's simple, but it's definitely doable. Don't feel stupid if you don't get it. I don't mean that. So this one and the next one kind of get into actuarial sciences. I don't know if you guys have heard of being an actuary. It has to do with insurance, so like it's kind of morbid. Like I'll figure out based on your weight, your age, if you're a smoker, your health, like when you're gonna die. Like on average, when people with these situations die, and then I want to sell you life insurance, so I want to make sure that I will have a positive expectation. Like I want to make sure that if you're going to die when you're 40 and I have to pay you $1 million, then by the time you're 40, I've collected more than $1 million. You know what I mean? So that's what actuaries do, like try to figure out the probabilities of death. Again, it's kind of morbid. Or like a car accident, like car insurance, house insurance, the probability of accidents, and they make sure that they have enough money to cover themselves, pay you out whatever insurance you claim, and then obviously they want to profit for themselves too. So this is kind of get into like number 10. Part B here is an actuarial example. Part A is just saying what's the probability this man does not die in the next 5 years. So like this is the probability I wouldn't have to pay out his life insurance. So the probability he does not die. Well, if I add all of these up, don't I get the probability that he does die in the next 5 years? So that if I know all of these, I think these add up to 0.00251. Does anybody have that? There might be another 0.
Yes, there's a
That's right. Thank you. So that's the probability he does die in the next 5 years. So all I'm doing is adding those up. So then what's the probability he does not die in the next 5 years? It'll be 1 minus that. 0.99749. I definitely want to do part B, but I want to do it tomorrow. We're going to skip to number 12. A couple of you guys have talked to me about, like, you're heard of or, of course, sort of interested in actuarial. So try 7B before we get here tomorrow and see how it goes. But we're going to jump to 12. Alright, so take a look at 12, read through it, and then we'll talk about it. I wouldn't write a ton in that space because we need like almost all of the space. Like this is my work from last time.
Oh.
Just to read through it. Alright, so I got a huge cookie jar, 65% chocolate cookies, so chocolate happens 0.65, 35% vanilla cookies, so vanilla happens 0.35. Choose 3 cookies, blindfolded, so it's random. I'm going to count the number of chocolate cookies. I want to take a look at that word, huge. It's not there, like, just for no reason. That matters. Don't say it, but take a second and you can see if you can figure out why. That is an important word.
Like the cookie jar is huge, or it just holds a lot of cookies?
That's the same as
So what's the difference?
Well, you could have a massive cookie jar with like 3 cookies in it.
Okay, it's a huge cookie jar with a massive amount of cookies. But why does that matter? Why does that have to be huge? Yeah, I got it.
Well, it's like taking away one cookie doesn't have as big of an impact as like 1,000 cookies.
Exactly. So if I had like 20 cookies, 13 of them will be chocolate because that's 65%. Well, now if I pull out a chocolate one, now how many are left? There's only 12, and that's different. 13 out of 20 and 12 out of 19 are like different, right? But if I have like a billion cookies, 6.5 or 650 million of them are chocolate, 350 million of them are vanilla, and I take one out, is that going to change the odds of the next one? Like, it's like, I mean, yes, technically, but it's so small, it just won't matter. So that huge is important. Okay, so what I want at the end of this is to be able to say, X is chocolate. Notice I wrote it like way off to the side. If I'm drawing 3 cookies, what are the possible outcomes? How many chocolate chip cookies could I possibly draw? I could get 0, 1, 2, and 3, right? So I could get 0 chocolate chip cookies, I could get 1, I could get 2, I could get 3. And what I'm looking for is those probabilities. So that I can go to my calculator, type in my L1 and L2, figure out the mean. But to do that, I gotta use a tree. So my first cookie might be vanilla, it might be chocolate. There's a 0.35 chance it's vanilla, 0.65 chance it's chocolate. So then I'm gonna draw again. The second one might be vanilla, might be chocolate. again. That one might be vanilla. Might be chocolate. And then I can use this to fill out this information over here. So if I think it's probably easiest. So let's just find all these probabilities first. So VVV. What's the probability of getting a V and then a V and then a V? Would that be 0.35 times 0.35 times 0.35? So let's say like 0.043. I'm gonna round a little bit. And then you can kind of shortcut the work. It's not as bad as you think. The next one will be VBC. The next one will be VCB. VCC. So I'm just listing all the possibilities. CBB. CBC. CCB. CCC. And then you can save yourself some time if you realize that there's some like overlap here. So VBC, you would multiply 1, 3 numbers together. 0.35, 0.35, 0.65, right? So if you have two V's and a C, you're going to do 0.35 times 0.35 times 0.65. The order doesn't matter. Because if you're multiplying numbers together, like isn't 2 times 5 the same as 5 times 2? So if it's got two V's and a C, I can just put 0.08 there. I don't have to worry about like actually typing in all of them. Know what I'm stuffing in here? So then VCC is the next one I'm blank. Would be 0.35 times 0.65 times 0.65. Let's say 0.15. So that's got two C's and a V. So two C's and a V appears down here twice also. So I can just write those down without having to type them in again. And then CCC is 0.65 times 0.65 times 0.65. So that's like 0.275. And now I can fill out that table. So 0 chocolates. What's the combination that gives me 0 chocolates? BBB, right? Which is 0.043. 1 chocolate would be this one, this one, and this one. So if you add those up, you get 0.024. See what I'm doing? 2 chocolates would be the ones with 2 C's. So that's this guy, this guy, and this guy. So 0.15, 0.15, 0.15, 0.45. This is not 0.024, sorry. It's 0.24, yeah, sorry. And then 3 C's is just CCC, which is down here, and that's 0.275. And then once you have this, do you guys know how to find the mean? Not just type in your calculator, 1 variable times L1, L2. So we'll keep going with this tomorrow. I'll probably do most of them tomorrow with you. It's pretty tough. We'll keep going next week. Question for me right now?